We're here today to talk about Jiffy pellets and rock wool for seed germination. On my right, probably your left, Jiffy pellets, compressed peat pellets, completely dry, and on my left, probably your right, rock wool. Now, rock wool is inert and sterile, which means we have to supplement it with nutrient and also pH adjusted water to compensate its own consistency. Now, Jiffy pellets, on the other hand, has got everything you could require for seed germination or for even taking cuttings, apart from the essential part, which is obviously water. So there's enough nutrient in there, there's enough compost in there to keep a cutting or a seedling going until it's got a good, healthy root system. Jiffy pellets are ideal for beginners, completely and utterly, due to the fact that all you have to do is soak them in water. Now, the key to Jiffy pellets is only to soak them for approximately 5 minutes. Now, that's dependent on how hot or how cold the water is. If it's very warm water, it take less time. If it's very cold water, it take more time. Now, what we do is, as soon as that Jiffy pellet is swollen to its potential, I'll pull it out to show you exactly how swollen it should be. The key with Jiffy pellets is do not over soak them. I cannot stress that more. If you over soak a Jiffy pellet, they end up waterlogged. When they're waterlogged, if you put a seedling in, the seedling will germinate or the cutting will take, but because they're so waterlogged, no air to the root system, and the root system will starve, resulting in possibly a dead plant. If not a dead plant, a very stressed plant. Now, we'll let the Jiffy go in the background while I talk you through rock wool. Now, this is the more professional way to cultivate seedlings or cuttings, but it takes a few variables to iron out before you get it absolutely right. Now, rock wool on its own with plain water wouldn't be good enough. You have to supplement it with nutrient, and then you have to pH adjust the water and the nutrient solution to compensate its own consistency, which we're going to do right now. Now, an ideal nutrient to use for seedlings or cuttings is one called Formulex. Now, Formulex is superb. It's tailor-made for rock wool cultivation. However, any grow A and B nutrient will suffice, as long as you make it up to a weak CF level. Now, CF, TDS, ppm, they're all measurements to verify the electrical conductivity of the nutrients in the water. In layman's terms, it means how strong the food is in the water, how strong your nutrient is. Now, Formulex is designed already to be very low in the EC value. Okay, it comes with full instructions on the back and tells you the dilution ratio. Now, you can follow that to the T and you'll end up in the right ballpark. What we are going to use, being more professional, are meters. Now, we have a pH meter and we have a CF meter, also called a TDS meter, also called a ppm meter. It's the same thing, it just measures how strong the nutrient is in the solution. I've just poured approximately 4 litres of water into this container for you to be able to see. Now, what we've basically got to do is raise or add enough Formulex into the solution to bring the CF level up to approximately 12. Okay, anywhere between 10 and 12 will suffice. But what is a good practice to do before adding any nutrient to your stock solution is just to test, before you do so, the conductivity factor of the water without any nutrients in it at all. Now, it's given me a reading of 4. I say, okay, that's a TDS level of 4. What that means is there's basically a conductivity factor of 4, which is dissolved salts into the water already, but that is what they would call blind water or duff. The salts it's gathered are actually dead salts. So it's given us a reading of 4. Well, that 4 is actually misleading us because it has no usable nutrient in there because it's dead already. Okay, so we have to make a note that that's reading 4 and add that to the equation. Now, 4 is quite high, so we always recommend halving the background nutrient reading and adding that to your stock solution. So if you're looking for a CF of 12 for the background for the rock wool, you want to add another 2 to the equation because we've already got 4 in the water, but that's 4 of dead salts. Okay. Now, to put that in English, we've got food in the water which is unusable food. What we're going to do is add food to the water. Now this pen reads exactly how much unusable salts are in the water. So what we got to do is take that and compensate against how much of this we put in. In so doing, it's reading 4, we're going to say, okay, it's misleading us by 2 because we're halving the original amount just to make sure that we're in the right ballpark. If you overfeed in hydroponics, you end up coming unstuck. If you underfeed, you always have a result. So always do everything by half and then look to step up. Now, what we're going to do is add some Formulex into the stock solution to raise the water up to a CF level of 12. 12 is absolutely ideal level for seedlings and cuttings. Okay, it's been tried and tested and scientifically proven that a level between 10 and 12 is approximately what a seedling or cutting would require, with a little bit excess just in case it does have a lot of vigour to grow. Anything above 12, you'll be doing your seedlings a lot of damage because it'd be too much dissolved salts in the water for the seedling to absorb. Now that would cause a problem to the root ball, it could burn it and therefore cripple your plant. Now, we've done this quite a few times, so what I'm going to do is put a wee splash into the solution. Okay. Now I'm going to give it a little stir. It's not the ideal thing to stir with as a nutrient meter, but it will suffice. And then take another reading. Okay, we're up to a CF level of 6 now, so we've got to add some more. I'm just going to get some pipettes to do it properly. Okay, pipettes are well worth using, obviously, because they have millilitres measured on the side of them. Now, in this, it basically explains that in hydroponics, you want 1 capful to 1.5 litres of water. Okay, now, instructions are great, but it's always best to do it yourself and confirm it with the meters. You know then you've got it approximately spot on. So what we're going to do is suck up another full meal, splash that in, and give it a stir. And it's always worth bringing it up gradually, slowly, and then that way you don't have to keep pouring nutrient away in order to get it right. We're now up to a CF level of 8, okay, so approximately another 3 mil should bring it where we roughly need it. Okay, we're now up to CF level of 12. Now 12 in this case is perfect. 10 to 12 is really where we want it. Now, once we've added nutrient, we then test for pH. You always test pH after CF, because adding nutrient to your stock solution adjusts the pH naturally. Now, 1 pH meter popped in, it's telling us that we have a CF or pH reading of 7.3. Now 7.3 is very high, too high for rockwool. Okay, if you soak that in that solution, put the seedling in, the seedling will be stressed because the pH is far too high for it to grow happily. Now what we have are 2 solutions, phosphoric acid, okay, and potassium acid. Now potassium acid is used to raise pH in your stock solution, where phosphoric acid is used to lower pH in your stock solution. Now the reason that these 2 bottles are in bags, sealed, is because when mixed together in a concentrate, they're diametrically opposed, which means that they conflict to such a degree that they could explode. And if these explode in your face, you end up in the hospital explaining why you got potassium phosphoric acid all over you. Whatever you do, always keep these bottles separate, always administrate them into the reservoir separately. What we recommend doing is actually having 1 pipette per job. Get some elastic bands, get some ink pens, and actually colour code 1 pipette per bottle. That way you'll never get muddled up. If you end up taking a pipette full of pH down, putting it in your tank, and then putting that pipette and some pH up, the pipette will explode, and it's not a very nice scene. Be warned, never mix the 2 together. They're quite safe diluted in a solution, but as a concentrate they're very, very aggressive. Okay, now what we're going to do is use pH down, because in this case the pH level is too high. So, we crank it out of the bag. Okay, 1 pipette over there. Get rid of that. Give it a little shake. Now, pH down is very, very aggressive. So you only have to administer tiny amounts. In this case, all we're actually going to administrate, I should say, is the amount on the exterior side of the pipette. Okay, so we've not actually put any in apart from the residue that's on the outer edge of the pipette. Then we stir it up and we retest. We could have possibly put 1 or 2 drops in, but as I said earlier, it's always best to underdo everything. Do everything slowly and do it again and again, and you'll get it roughly where you need it. Okay, we've just lowered the pH through doing that down to 7.2. So what we do is we do that again, but in this case have a little drop as well. So 1 tiny drop and a little bit of exterior on the pipe. Pop it in. We can have a stir. Okay, we're down to 6.9, so we've still got a little way to go. Okay, 1 more little drop. We've got it down now to 6.1. 6.1. So 1 more go at that. Give it a good stir. Okay, 5.7, 5.6, 5.6. Right, that's good enough. The value I was looking for is 5.5, but 5.6, 5.5 is roughly where you need it. Good enough. You don't have to get it absolutely spot on. If you take it too far down and you've got to use pH up, which you don't want to do, you'd have to throw the stock solution away and start again. You don't want to use a lot of pH up and a pH down together at this stage for seedlings or cuttings. If you use too much of it, it's very, very aggressive and it can do the root system a lot of damage. If you end up taking the pH too far down, you're much better off throwing the stock solution away and starting again from scratch. Okay, so we've got the level now to 5.6, which is good enough. Ideally I would have wanted 5.5, but 5.6 will suffice. I don't want to take it down any further in case it goes too far down. Now, what you've done basically is added nutrient into the solution to a level of CF at 12 or TDS at 12. We've then adjusted the stock solution down to a pH level of 5.6. We're now ready to soak the rockwool cube. Now, while that's soaking, our jiffy pellet is finished. Okay, what was a very squashed peat pellet, compressed, is now a very swollen sack of dirt. Now that is basically the consistency where you want it, where if you give it a slight squeeze it drips. It's wet enough to keep your seedling going for at least 3 or 4 days, but it's also wet enough to let air in for the root system to breathe. Now what you would do with a jiffy pellet, I'll use a different pipette, is make a hole approximately 3 mil beneath the surface, 3 to 5 mil. You'd then pop your desired seed into the jiffy pellet and then cover the seed over. Okay, you would cover it over to a degree where it's cocooned in the dirt itself. The seedling has to be cocooned to keep the moisture completely around it to encourage the seed to germinate. At that point it's then ready to go into your propagator. Perfect. Now, while that's been soaking, our rockwool was sunk down to the bottom. Now, some people like to soak rockwool overnight. It allows the chlorine to rise, and that way when you pull the rockwool out, it doesn't have a lot of chlorine in the actual rockwool itself. However, you don't have to. I mean, to be quite frank, as long as it's soaked and sunk all the way down to the bottom, it's good enough to receive the seedling. Now, the key with rockwool is now to give it a squeeze. Okay. The idea of a squeeze is to get approximately 5 to 10% of the volume of water out of the rockwool in order to get oxygen in. If we put a seedling in without the squeeze, you end up with a waterlogged rockwool block. When you put the seed into a waterlogged rockwool block, Same thing like the Jiffy, it ends up rotting because it cannot breathe properly. A seed or a cutting needs just the right amount of food, not too much, just the right pH level and just the right wetness. Not too wet, but more wet than dry. So the key to it is just to squeeze 5 to 10% of volume out of the rock wool itself. So we've got water in there, we've got nutrient in there, we've got air in there, we've got everything the seedling needs. We then make, just like in the Jiffy pellets, approximately a hole 5mm beneath the surface. We then get the seed and pop the seed into the hole and then gently cover the seed over. Now with rock wool, do not pinch it tight. When you're covering the seed over, you have to do it gently. A seedling only has enough inertial energy to get up, okay? If it's blocked, if this rock wool's been squashed too tightly, it will not fight its way through to the surface, it will end up dying. So you just cover it over gently and then it's ready to go into your propagator. That's how you do rock wool, that's how you do Jiffy pellets. pH meters are semi-waterproof up until the first ridge on the meter. If you accidentally drop them in, fully submerge them, you want to pull them out and turn them off and put them on a radiator and dry them out. There's a good chance they'll come back to life. However, they might be completely and utterly fried. So they are semi-waterproof but not fully waterproof. And they work after, well, it's a good idea to give them about 5 seconds in order to give a proper reading because it can fluctuate because the temperature of the water it has to compensate for. And that's a pH meter. And then always turn it off after use, because if you leave it on after use, it ends up wearing the batteries out, which is going to give you a fake reading the next time you use it. So switch it on, dip it in, get the reading you want, turn it off. At that point you then adjust your solution. Okay, we've just talked about pH meters and CF meters. pH, CF, also known as TDS, ppm, so on and so forth. It measures the amount of food in the reservoir, that measures the pH level in the reservoir. Now, it's very good practice once every couple of weeks to calibrate your meters. If you don't calibrate them, you don't know that they're reading a true reading. In so doing, you could be feeding your plants too much or too less, or you could get the pH completely and utterly wrong. Now, on a pH meter, you use a solution called Buffer 7. Buffer 7 is specifically balanced at a pH level of 7. Okay, what you'd basically do with this is pour it in a cup, dip the meter in, and then see exactly what the meter is reading. There's a little screw on the back and a little screwdriver that comes in the case, and that is how you would adjust the level of calibration. What we're going to do is actually do it right now so you can see. So what I'll do is pour Buffer 7 into a glass. We then turn the meter on and then dip it in. Okay, now what we've got is a reading of 7.2. So 7.2 is slightly high, so it needs a little bit of adjustment. So we'd put the little screwdriver in the back, give it a little twist one way. I've gone too far that way, so then I'll go back a little bit the other way. A little bit of fine adjustment back and forth till we get to a pH level of 7. Now that meter is now perfectly calibrated, pH at 7, so we know it's true. That's how you pH calibrate. This is how you CF calibrate. This pen uses a different calibration solution. They call it conductivity standard. Okay, basically it's stable at CF level of 27. So when you pour that into a cup and you pop the meter in, the reading you want to be looking for is 27. If it's too high, if it's too low, same story. You put the pen in, screwdriver in, twist it one way or the other till you get to 27. We'll do that for you right now just to show you how easy it is. So pour a little bit in the glass. Get your TDS meter, pop it in. And this is actually showing me a reading of 27, so I don't need to do any adjustment. But if you did, just stick the screwdriver in the back and turn it one way or the other to compensate. And that's basically how you simply calibrate meters. Now, a lot of people think that's very difficult, but I can't see why. Ideally, once you've used your solution in a cup, they recommend to throw it away, because the more air and the more contact it has with other surfaces, the more unstable it becomes. However, it's a bit puritanical and you can get away with pouring it back into the bottle. It's good practice to throw it away, but you can get away with not, okay? Which a lot of these fluid manufacturers won't tell you about. That's how you calibrate. You put the seed into the rock wool or the jiffy pellet, or even both, depending on what you fancy doing at the time. They then would like to go into a propagator. A propagator basically acts as like an external womb for the rock wool, the jiffy pellet. It creates maximum humidity in the environment. In so doing, it stabilises the environment, encourages the seed to germinate. Now, we recommend putting your seedlings and cuttings in. They don't want to be sat in a puddle of water, okay, but a little bit of excess water in the drain is not going to hurt. But, as I said, do not let the rock wool have direct contact with that puddle of water. In so doing, the rock wool or the jiffy pellet will become waterlogged, and that will be no good for your seedlings. Now, what would happen is you'd put them in, you'd shut the lid, and you'd then close the air vents. And before long, the whole chamber becomes covered in moisture and condensation. You would then put that in a very warm sort of environment, airing cupboard. If you have a heated propagator, you don't have to worry about that, you just turn the heat on. However, that's dependent on the time of year. If it's anything like the weather at the moment, which is approximately 30 degrees, you don't need to put that in an airing cupboard. Okay, it will do quite happily on its own in a normal room. If it's the middle of the winter, then ideally it would want to go somewhere like an airing cupboard, just for the initial germination process. Okay, no light is needed at this point, it just needs to go somewhere warm. Warm but not very hot. Now, over the course of possibly 24 hours, but it could also take up to 7 days, the seedling would germinate. It will start to grow, and it will start to develop. Now, initially, it will have basically it won't look much like a plant at all. As soon as you see any sign of life, anything breaking through the top of the rock wool or through the top of the jiffy pellet, then it's time to employ some form of lighting. Either put that by the windowsill or put it actually under your light. Now, if you put this by the windowsill, seedlings cannot tolerate direct sunlight. If they get direct sunlight on a hot summer's day, then there's a good chance that they'll fall over because they won't be able to take the intensity of the light or the heat generated from the sun. So ideally they'd want to go under a propagation light. High frequency fluorescent lights are perfect for that. Mercury blend 250 watts are perfect for that. Now, if you are going to use an industrial light like the high intensity discharge, metal halides or high pressure sodiums, you want to make sure they're an adequate distance away from the canopy of the propagator. If you're using a 400 watt high pressure sodium, for example, I would want it approximately 3 to 4 foot away from the canopy of the propagator. That should have enough distance between the light to the actual seedling itself that the light dissipates down to such a degree that it's adequate light for them, but not too intense. Right, with a 400 watt light, approximately 3 to 4 foot away from the lid of the propagator. Okay? And you'd want to run that light, well, I'd have it at least 18 hours a day, possibly 20 hours a day. So about 4 foot away is approximately there from the actual lid. Now, I wouldn't run the light 24 hours a day, as a lot of grow books say. What you will find is if you run a light 24 hours a day for seedlings, you end up stressing them out. And undue stress is not what they need at this particular point in their life. They're very, very fragile and they need an easy breaking in, not a hard one. So give them a sleep. The whole of nature, to my knowledge, requires sleep. Why are seedlings going to be any different? These books that state 24 hours lighting, it can work in a lot of cases, but it also has a lot of detrimental effects that I don't tell you about. So, lighting on for approximately 18 to 20 hours a day, approximately 4 foot away from the canopy. The seedling will start to grow. Before long, it will develop leaves. Now, ideally, what will happen is, before it's developed enough leaves or sustained itself to a degree where it can be transplanted into another system, you would want to break it in to a bigger rock wool cube. I.e., what will happen is roots will grow out the side and the bottom. they're going to become root bound before you can actually get them into another system. However, they're still very young and still very fragile. So what we recommend doing is, as soon as any roots start growing through the side and through the bottom, you then need to transplant that rockwool cube to a bigger rockwool cube, and then put it back into the propagator and propagate for some more. I'll get you that cube just to show you it. Right, this is a whole strip of rockwool cubes. You break one off. With the stock solution, again, adjust the CF level to around 12, then bring the pH down to 5.5. You can use Formalex, again, it's tailor-made for rockwool, or at this point you can go to Grow A and Grow B nutrient solution. But again, when you add the Grow A and Grow B, you have to make it to quite a weak CF level, to approximately 12, which, if you was measuring it from the instructions on the back, 1/3 the dilution ratio they tell you on the back. So what you would then do is drop your rockwool cube into the stock solution, allow it to saturate. Again, you can leave it overnight if you wish, otherwise just let it get to the bottom and then pull it out. Give it a squeeze to get rid of approximately 10% of the water content from the cube, and then, without damaging the roots that are already there, ease it into the block and then squeeze it tight. That would then go back into your propagator, okay, and you would then water it less. Because it's in a much bigger medium, it holds the water more. So at that point you'll probably find you need to water it every 4 to 5 days instead of every 2 to 3 days. Ideally, I would then want to propagate with the lid on until you've got at least 3 to 5 sets of leaves. Now, if you're in a jiffy pellet and the roots have grown through the side and bottom, we still recommend going into a bigger rockwool block. So although you've avoided doing the pH adjustment and CF adjustment to get the seedling going, you now have to do it for the bigger rockwool block. Once you've done it, same thing would apply. You'd soak it, get it to a level where it's completely saturated, give it a wee squeeze, and you'd put the jiffy pellet in its place. That would then go back in the propagator. Now, ideally you'd want to propagate till you've got 3 to 4 sets of decent leaves. I'm not talking about leader leaves, the original set, I'm talking about decent leaves. So fundamentally what you have is almost a very small plant. At that point you know it's a secure plant. Even if you shot the life out of it, it shouldn't die. It's at a point now where it's eager to live and strong, and it can survive most situations. This is the point, if I was a beginner, I would then transplant it into the system. However, I would wait until roots are grown through the bottom or grown through the sides. Ideally, you do need to see root systems coming through the side or bottom before going into your system. Most systems run on a lot of water. Now, if the rockwool blocks become absolutely saturated and the root ball isn't through the rockwool block, then what will happen is it will starve itself of aeration and prohibit the growth of the plant. So wait till you've got nice roots growing through the side and bottom, 3 to 4 sets of decent leaves. At that point it can go into your system. That is seedling stroke young plant propagation process finished.
Do as much as you want, then we'll chat the intro on after.
Okay.